Hi, and welcome to OpenSearch, Building the Future of Search Together. My name is Jules Graybill. I prefer the pronouns he, him. I'm a director at AWS responsible for the open source OpenSearch project. Presenting with me today, I'm really excited to have Saurabh Mehta. Saurabh uses pronouns he, him, and Saurabh is a senior engineering manager responsible for observability at Airbnb. We're going to talk today about what OpenSearch is and some of the motivations for the project. This has been a big year for OpenSearch, and we're going to talk through some of the main events that happened, look at the roadmap for what's coming up in OpenSearch, talk about ways that you can be part of the project, and then Saurabh is going to talk us through how OpenSearch is helping Airbnb solve some of their observability challenges. Let's get right into it. So what is OpenSearch? OpenSearch is a suite of tools centered on a search engine, also called OpenSearch. If you are aware of Elasticsearch and Kibana, a lot of parts of the OpenSearch project are going to look familiar to you. So OpenSearch itself, as well as the web interface, OpenSearch dashboards, and a whole set of supporting tools and plugins that add enterprise-grade features and make it easy to use OpenSearch in your application. People use OpenSearch for all sorts of use cases. The most obvious one, of course, is text search. It's a powerful search engine backed by the Apache Lucene project. It provides a distributed inverted index for performing full text search on any set of data. It has great support for natural language searching, Boolean queries, faceting, a broad set of written languages that it supports, and robust relevancy tuning capabilities. OpenSearch is also great at importing high volumes of data and making it available to search in near real time. Data you import into OpenSearch is sharded and distributed across your entire cluster, enabling high volume indexing and high performance querying. What's not intuitive at first is that when you combine a powerful search engine with high performance streaming indexing, it's a power combination for analyzing machine generated data, such as log files, and using those data to provide visualization tools and analysis that give you insight into what's going on with that log data. Here's an example. This is an Apache HTTP server weblog. Apache weblogs contain tons and tons of data, but the signal you care about can get easily lost in all the noise. With OpenSearch, you ingest and index log files like this. It indexes the data. It stores numerics in a format that makes it easy to do fast aggregations and quick analysis. And then you can use OpenSearch dashboards to create dashboards themselves that let you monitor and look into this data. OpenSearch dashboards has a variety of charting tools, makes it easy to drill down and find individual records, and perform ad hoc queries. With OpenSearch and OpenSearch dashboards together, you can centralize the volumes of data in your logs. You can search for errors, build visualizations to get right to the information you care about. It helps you turn raw data into insights. We created OpenSearch because the community asked us to. OpenSearch is 100% open source software. It's all released under the Apache license version 2, which is a well-known, broadly applicable license. What's great about open source software is that builders can use that software in applications, in products, in businesses that even the creators of the software couldn't imagine. And open source software and the freedoms that it gives have enabled a lot of the innovation in products and experiences and technology that we use every day. AWS is the steward of the project today, and we're making a lot of efforts to ensure that all the decisions we make incorporate a lot of community input. We're entirely transparent with our roadmap. We put RFCs out before we create any features or make changes that we're considering. And we've welcomed several co-maintainers to help us keep parts of the project really relevant for anybody who would want to use them. On top of that, OpenSearch is really full-featured. We started with the open source distributions of Elasticsearch. On top of that, we added fully open source implementations of in-demand features that customers were asking for, such as security, machine learning, and analytics. What this means for you is that if you're using Elasticsearch today and you care about using an open source product, if that's a priority for you, you have a path forward. OpenSearch is available to run in any environment you want. You can run it on premises, you can run it on any cloud, you can run it on AWS. It works equally well everywhere. If you're using Elasticsearch today, if you're using open source Elasticsearch today, and you want to migrate over to OpenSearch, really no changes are going to be required in your application. And like I mentioned, we're adding lots and lots of features and continue to do so all the time. OpenSearch launched this year, but our experience at AWS working with technology goes back a lot further than that. Elasticsearch itself was released in 2010. In 2015, we launched the Amazon Elasticsearch service that made it available to customers as a managed service. In 2019, we took a lot of the additional features that we had added to Amazon Elasticsearch service and released them in open source as OpenDistro for Elasticsearch. OpenDistro was a distribution of Elasticsearch that included open source Elasticsearch, open source plugins and extensions, and all packaged together and made easy to install and use. In 2021, we added OpenSearch. And OpenSearch is all the functionality that we created as part of OpenDistro, now for the first time combined with open source software that ran for the full stack. So now OpenSearch is an entire distribution, fully open source, available in one place. We announced OpenSearch earlier this year. Since the announcement, we've been really busy. We've released 3 versions of OpenSearch. We've made our roadmap public, and I'm going to show you some of the roadmap and walk you through that a little bit later in this presentation. Community response has been incredible. There have been a number of community projects and partners who've launched things with OpenSearch and built things with OpenSearch, and we're featuring all of them on the OpenSearch website. I encourage you to take a look. We've also added dozens and dozens of features, and adding new features is something that is really a priority for us. I want to dive into a couple of them. There's way more here than I could do justice to in a presentation today. But there are 2 that I think illustrate some of what our priorities have been for OpenSearch. One of those priorities is making it really easy to manage OpenSearch at scale. And that we believe that doing so lets you put all your data into OpenSearch, as much data as you want, and really get the advantages of putting all your data in one place. Then also, we are focusing on making it fast and easy, almost magical, ideally, to get actionable insights out of OpenSearch. So let's talk about the first one. As people are putting more and more data into OpenSearch clusters, those clusters are becoming more important to them. And the availability and responsiveness of those clusters really start to matter to them. They look for creative ways to achieve higher and higher resiliency. One of the creative solutions is actually to run multiple OpenSearch clusters, put different clusters in different data centers, and then put the same data in both of those clusters. That gives you great geographic isolation. If there's an extended outage in a world region, you still have access to your data, and it helps you move your data closer to your users. The downside to this is that duplicating your data and keeping it in sync across multiple clusters is a real pain, and the manual techniques for doing so are just generally unsatisfying. What we did to help make this easier was we created a feature we call cross-cluster replication. It's available in OpenSearch 1.1. You can go download and try it today. What cross-cluster replication does is it allows you to write your data to a leader cluster and then identify a follower cluster that will go pull that data and keep itself in sync with your leader. The follower cluster is going to guarantee sequential consistency, and generally you can move your data to anywhere else in the world in less than a minute. What's neat about cross-cluster replication is it also works at an index level. So if you are generating machine data or logs in multiple data centers, you can write to your close-by cluster and then set the other cluster to go pull that data and keep itself in sync. So to be a little more real world about this, let's say you have a data center on the eastern seaboard of the US. You're writing log files into that data center. And then from data centers in the rest of the world, you're going to go pull this data and keep it in sync with cross-cluster replication. And then for you users who are reading the data and doing searches, they can access the data in the closest geographic data center to them. So they get a really responsive, fast experience. And all of this is handled automatically. It's powerful, it's really robust, and it's easy to use. It's been a really popular feature. I encourage you to try it out. The other feature I want to talk about is anomaly detection. Real-time automated anomaly detection. We built this into OpenSearch a few years ago. It helps you detect anomalies in your data, which is something that people have really wanted to be able to do. We use an algorithm called Random Cut Forest that is really optimized for analyzing and finding anomalies and streaming data. It's a machine learning algorithm, but what's great is that if you are not a machine learning practitioner, you can make full use of it. I love this testimonial from MobileWallah talking about how they've made use of anomaly detection in OpenSearch. They say we integrate with hundreds of our customers using the Amazon S3 API for data exchange, and we monitor their traffic patterns by analyzing S3 access logs in Amazon OpenSearch service. Anomaly detection has helped us detect changes in traffic patterns without configuring complex rules for each customer. This has enabled us to respond to those changes in a timely manner, ensuring security and reliability of our platform. We launched real-time anomaly detection last year. This was an open source feature right from the beginning in the Open Distro for Elasticsearch product. The anomaly detection supported up to 5 dimensions, so you could look at 5 different dimensions of your data, typically something like CPU and memory, and we integrated it with OpenSearch alerting so that as soon as an anomaly was found, OpenSearch or OpenDistro at the time would let you know. This went over really well, but customers wanted more. Specifically, 5 dimensions didn't necessarily match what the amount of cardinality that they had in some of the data they wanted to monitor. So later that year, we launched high cardinality for anomaly detection. This lets you look for anomalies on up to 1,000 unique entities, looking for something like CPU anomalies on a host relative to the previous performance of just that host. This helps customers who are running large collections of servers who want to look for anomalies on every server to spot and identify those at a server-by-server basis. This was a welcome improvement, although we found that customers were still finding 1,000 unique entities to be a limitation that they didn't want. So we went back to the drawing board and rewrote the RCF algorithm from the ground up, adding support for up to 1 million entities. That launched as part of OpenSearch 1.1 earlier this year. So now customers who have large fleets of microservices or who want to look at customer by customer anomalies can use automated anomaly detection to do so. It's been a big hit. And of course, customers are still unsatisfied with many of the features in anomaly detection and still asking for more, and we're continuing to work on it. So let's talk about what's next. The roadmap for OpenSearch has 3 big focal areas that we're thinking about right now. The first is enhancements to core OpenSearch. And a lot of those enhancements are focused on reliability, manageability, performance, and cost. If OpenSearch is efficient and performant, it allows you to put all your data into an OpenSearch cluster without having to worry about costs. And we know that this can be expensive and that customers really care about this. Small changes and small improvements can make up for big cost differences. And we're looking at small changes and also some big changes. OpenSearch is powerful, but it's not always for the faint of heart. And so we're doing a lot to improve ease of use and the getting started experience. We're creating a drag and drop visualization builder for OpenSearch dashboards that let you more easily go explore and try different visualizations with your data. We're releasing artifacts from more operating systems more frameworks and container frameworks and orchestration systems, really looking to make it easy to bring OpenSearch to you, however you want to install and run and manage it. More features are coming for anomaly detection. We're doing continuous work on that. And we're rethinking the way that OpenSearch does notifications to make it a little easier to use for lots and lots of use cases. And then lastly, we're putting a lot of focus on log analytics. Machine-generated data is growing year over year, and users really want someplace to put their logs that makes those logs useful. So OpenSearch is such a great fit for this. We're continuing to find ways to make it work better for the log analytics use case, including an event viewer that we're launching soon, lifecycle management for your indexes, and integrated machine learning across the whole system. So these are some trends in our roadmap, but the actual roadmap is available for anybody to go look at. This is one of the big changes that we made this year. We took our roadmap and published it on our website. So you can go to opensearch.org and click the roadmap button on the top right of the web page and see a table that looks something like this. Each column represents an upcoming OpenSearch release with the planned release date. And within that, each card is a feature or a distribution type or something that we're thinking about adding. Each of the cards here links to a GitHub issue where you can follow up for details, you can ask questions, or you can offer to contribute in some way. And speaking of contribution, one of the questions that we get asked a lot is, how can I be part of this project? How can I contribute? And there are a lot of ways that you can participate. The easiest is, and the best way to get started, is to join the community forums. We have a really active, thriving forum where users are helping each other solve problems, they're giving feedback to the developers, they're asking questions, and they're really helping each other out. I encourage you to go join, ask your questions, answer some questions, get to know the community. We've done several community-contributed blog posts where somebody wanted to talk about a way that they are making OpenSearch useful for their use case or a feature that they're considering developing or adding. If you have a blog post in mind, get in touch with us and we'll help you get it live. Software can always use more documentation. OpenSearch is no exception. And so if there's an area where you think the documentation could be improved, submit a pull request and let us know. We'll work with you to make that live. And then, of course, you can contribute code to OpenSearch. There are a few areas where we're really looking for code contributions. One is language clients. If you want to use OpenSearch from a programming language that you particularly care about, you're probably in the best place to know the really low-level details of how that client ought to work. So come co-maintain that with us, and we'll make sure that we build something that's really relevant and useful to you. Earlier this year, we launched a great plugin template to show people how to easily develop OpenSearch plugins. We'd love to have a similar one for OpenSearch dashboards. A lot of customers want to run OpenSearch with Kubernetes and are looking for a centralized Kubernetes operator. And that's something that there's a lot of opportunity to come create. And then if you want to run OpenSearch in your environment, in your operating system, on your platform, come help us get that right. Next, I'd like to introduce Saurabh to talk about how he's using OpenSearch at Airbnb.
Thank you, Jules. Hi, everyone. Thanks for having me. My name is Saurabh, and I'm representing the Airbnb Reliability Engineering team here. Airbnb, as you know, has become a noun, and our community has been growing substantially from where it started back in 2007. True to one of our core values, be a host, open source is at the heart of Airbnb. We have many successful open source projects, which were created at Airbnb, and we actively adopt and contribute back to various open source initiatives to be part of the open source community. So today, I'm here to talk about OpenSearch, how we use this at Airbnb for various use cases, and what problems we are solving with this. And I would like to further expand specifically on observability use case, how we are leveraging OpenSearch what problem it's solving and some of the general challenges associated with observability and where OpenSearch fit in. And I would like to end with the opportunities that are forthcoming and how we are planning to integrate them into our ecosystem. So let me start with OpenSearch at Airbnb. We use OpenSearch for various use cases, some of which are customer facing, and some of them are internals. As you can see on the slide, there are critical use cases that we leverage OpenSearch, and it scales for our need. Whether it's reservations, payments, reviews, Airbnb help, or running our promotions on the site. We also use OpenSearch for observability use cases such as logging and tracing. Further going into details about our observability use case, we operate at scale for our logs in hundreds of terabytes per day, and we have tens of clusters to support all these use cases. Now, this service is used by every engineer at Airbnb to help prevent and debug any issues during the development or while running it in production. Logging is critical for our availability needs, which while resolving any production outages, and it is a useful tool during the development lifecycle to help prevent issues in production. OpenSearch offers the flexibility that we need with respect to storing the data in appropriate tiers, as we keep the recent data in hot tier versus older logs being pushed to warm and cold tier. This flexibility allows us to control the overall cost that comes with the scale. We have also made this feature self-managed for every team, so they can make the changes as they desire based on the individual team needs, apart from a default quota that applies across all of our logging use cases. Now let's talk about challenges. You all must be familiar with the general design for any data pipeline, specifically in terms of observability, where we collect the data, transform it, store it, and then access it to generate insight from it. However, there are certain challenges associated with that. Starting with the data collection, there are multiple standards to instrument your code. Most of these libraries are available on server side, whereas native and web have multiple gaps associated with the overall observability story. On top of that, there are multiple sidecars that you need to run, deal with legacy code bases, or integrate external third-party tools for monitoring, which pose significant challenges. This leads to significant churn and results in data coverage gaps, discrepancies, and operational overhead to manage and run these services. Now, speaking of the data storage layer, there too we have disjoint storage engines with varying performance in terms of IOPS, and it's often hard to add support for new signal type if you need to. On the access side too, there are different tools to view this data, different query languages, resulting in lack of alerting and correlation between the data. This often results in overall poor experience for users of these tools and the tremendous amount of work for the team managing this infrastructure. Now let's talk about the opportunities. As observability in general moving towards standardization, and what opportunities we see here coming from that. It's important for us to think observability as a practice, which would help in different phases of software development and be adopted across the depth and breadth of the product and infrastructure. Now, these three steps are important to connect and draw actionable insights at every step in order to get the maximum benefit from the operational data. We see preventing an incident or outage to happen in the early phase before it goes to production is far more beneficial, saves time and money, but so is detection and automation, which takes observability into a space where we can truly harness the power of the data. Now, with the OpenTelemetry project, we see an opportunity to standardize across the signal set with drop-in instrumentation, support and development on open standard. We see a huge opportunity to standardize and remove all the gaps that we discussed in the challenges slide. There are similar opportunities that are being presented for the storage engine side as well, as we see OpenSearch supporting logs and traces, and Prometheus and Cortex becoming the de facto for metric storage. This goes beyond that with query language standardization and provides opportunities to view the operational data as in whole. Now, how are we positioning ourselves at Airbnb to leverage these opportunities? We are working to standardize our instrumentation on open standards by adopting OpenTelemetry. We believe this would help bridge the gaps that we see today, which eventually will result in preventing the incident. Bringing this data together with common access helps in signal correlation and generating actionable insights from them, which in fact results in the reduced outage times. But we shall not stop here. The true power of harnessing this data would be to move towards automation, as this platform supports first-class APIs, which gives an opportunity to develop closed-loop system, anomaly detection, and that some of those features, as Jules has discussed in his presentation as well, which in turn increases the overall developer productivity, because they have to worry about those issues less. So along with that, we are also working to integrate the GitOps model into our ecosystem, which helps to standardize how we access this data, how the alerts are being created, how the dashboards are being managed. So that way we have a centralized storage for all this ecosystem. With that, I'll hand it over to Jules to conclude this presentation. Thank you so much.
Feel free to reach out to us with any questions or follow-up. And of course, I encourage you to go to opensearch.org and try OpenSearch for yourself. Thank you.